Hi everyone. So this week we are starting Newton's laws of physics, or Newton's laws of motion, as they're also sometimes called. And there's 3 laws that we're going to be taking a look at. But even before we get into the laws, I wanted to give you a little bit of a foundation on forces and what those are really all about. And certainly the basics of forces, you might know that they're just pushes or pulls, but there are different ideas about forces in terms of balanced and unbalanced forces. And there are all these forces that are kind of acting around you all the time, like gravity and friction. And so how they affect the way things occur or the way things work on Earth are pretty significant. So as we take a look here, we've got I've got a couple of GIFs for you to take a look at and think about. This apple on a desk, which would have been one of the traditional do-nows that we would have done in the classroom. We're just going to do it here. And then I've got a short video on forces, an article, and then I've got this PhET simulation that I want you to take a look at. So when we take a look at the PhET, the interactive, the default when you log on to it, you notice it went right to net force. I actually, if you'll see in the directions here, I actually would like you to select friction because it works a little better. So you're going to select friction, turn all the boxes on, and then I want you to change the applied force to 500 newtons, and we're going to see what happens here. So friction, right, we'll start that, check all the boxes. It allows you to kind of see what's going on, and then we're going to change this to 500 newtons, okay? So you kind of gave it a push, and then you're going to kind of see what happens from there. So I like the interactive because it's not like if you do X, Y happens, and that is going to be the same experience for every single student. For this first part, sure, but you all have an opportunity to play around with it a little bit and see what you can make happen. And so you might find that the way you got something to happen could be a little bit different than the way someone else got something to happen. So it's really a true exploration, a true interactive, in the sense that there's not just one outcome and you have to get the one outcome. Now, to that end, I've got some questions for you that are basically saying to you, look, how did you get this to happen? How did you get a force, a push or pull applied, but no movement? What did you have to do to set that up? How did you get a force to happen that was unequal, right? Because one of the things you're going to be reading about and learning about here are what we call balanced and unbalanced forces. And it really is just what you would think, right? Things that are balanced, right, are kind of equaled or canceled out, and unbalanced are unequal or not canceled out. And the things that are not canceled out are what result in some kind of change. And that's a big thing with forces because it's the idea that you result in change. And so sometimes people always assume that you result in movement, and oftentimes that can be, but it could just be that your movement changed, because what if you are already moving to begin with? So just some ideas to consider. I've got a good little Ellen video, because she's always good for a laugh, far better than me. And so we'll get into balanced and unbalanced forces, the net forces, and net is just kind of what you end up with, what you actually get in the end after you take away or subtract all the things that have canceled out. And then we're going to get into Newton's 3 laws. I've got law of inertia, and I did a little example of inertia for you. It's not my best work, but it worked. So you can see me attempt a little bit of a ninny on this one, but I got it done. Second law and third law. So we'll go through each of the laws, and again, I've got another GIF here. ouch, that looks like that hurts, right? But that's what happens when you shoot an arrow at a concrete wall, because why would you do that, right? So then we've got your choice at the end that I want to talk about quickly, which is to either answer all the questions that are here on the right-hand side for this last section, or you can create your own video. So you have an opportunity. I got a chance to make myself look a little bit silly, but you have your chance to do something actually kind of fun. And there's lots of different things out there that you can do with Newton's laws. And you can even do multiple little ones if you want, or one big one. But I've given you some suggestions like water bottle rockets or balloon cars, and those are fun. But there's lots of ways that you can demonstrate Newton's laws of motion in real activities, and just talk about it as you're doing it, and talk about how they're actually in action or in effect while things are going on. So you've got to upload that if you choose to do that. If you don't choose to do that, you just got a bunch of questions here that I'm going to ask you to answer. But again, I think you'll have a lot of fun with it. I had fun with it because it's always fun to be silly. So hopefully last week of work, that's awesome. And then you'll have a week of catch-up stuff and other things that we've got planned. So take care. I hope you're doing well. I know the weather's great, and I appreciate that you're sticking with us. All right. Bye-bye.